So the problem we're going to look at, we've got what we call a balanced number. A balanced number has an even quantity of digits.
These students are developing their understanding of proof with a mathematical problem that introduces proof by exhaustion.
The task was looking at a 4-digit balanced number, so the first 2 digits of the number had to have the same sum as the last 2 digits. And the available digits to them was 0, 1 to 5, and they could use any digit as many times as they wanted. They were told that there was 125 different ways, and they had to prove that there were 125 different ways.
So you need to start with 1, 0, 1, 0. Just start like that and then see if a pattern builds.
Initially, all the groups just started writing numbers down that they knew worked and that were balanced numbers. Quite early on, 2 or 3 of the groups started grouping their numbers, and most of them started by grouping them by the digit sum. So they started off with the smallest digit sum of 1 and looked at all those numbers with a digit sum of 1. Then they moved on to a digit sum of 2, and then they carried on with a digit sum of 3. Some of the groups started at the other end. They started with the biggest digit sum of 10 and worked backwards. But nearly all the groups were starting to group their numbers, and they realised quite early on that they didn't have to write every single number out, because that would have been a lot of work and exhausted them. Is this grouped by...
That's the kind of the total of
the digit sum.
Side.
Good, that's a really good way of grouping them. Have you missed anything?
That's what I'm just going over now to make sure that I've got them.
Have you missed any here where the digit sum is 2? Can you combine some of the ones?
Oh, you could do like 1, 1 and 2, 0.
Oh my
Think
God.
about those
options.
Sometimes I think as soon as they've got a pattern, they just assume it's right without testing it. I think that's a hugely important lesson, is to be spotting patterns, but they also need to be convinced that their patterns are right, understand when that pattern might change and test out that pattern, and understand why it might start changing direction or going in another way.
Whoa. Is that all the combinations you're going to have for one?
I think so. 1, 2, 3, 4, 5, 6, 7, 8, 9.
There was just 1 and a 1 and 2 and 0.
16, 17.
17 is such an... It can get a bit confusing at points when you're both trying to do the same thing but in a different way.
What was the digit sum for this group?
They add up to 1, they add up to 2, they add up to 3.
So maybe write that aside, what the digit sum is for each group.
This is the sort of maths you can't do on your own. So like if one person has a good idea, then you can develop that. And if you're going wrong, then they can help you. It's less frustrating. Yeah. And then other people find your mistakes that you might not have spotted.
Working through the whole thing will take a while on your own. So doing it in a group, kind of split it up, and if you kind of stuck on one point, you can work as a group and try and work out that kind of the area together.
But it was interesting to hear on reflection how they enjoyed working together, and I think it's something that we need to encourage a lot more in the maths classroom, is getting our students to talk to each other and share ideas and learn from each other. And I think when you have a discussion about a problem, you remember it and you remember what you talked about far more than when you do something on your own or when you're just listening to somebody else telling you what to do.
So that difference.
I think a proof by exhaustion's a nice method because you're often told what you're looking for and what you're trying to arrive at. They all knew straight away how to get stuck in and they all had a go at it. And I think you reach a point where you might get a bit confused and muddled and they needed to talk to each other and they needed a bit of probing. But I think if given enough time, they would all get there in the end and realise that if you persevere with it, you can find a solution in the end and reach a conclusion.